This problem states the angles of depression of two ships A and B as observed from the top of a lighthouse 60-meter high are 60 degree and 45-degree respectively. If the two ships are on the opposite sides of the lighthouse, okay, so you see the phrase here, opposite sides, right? In the type 1, we had on the same side. Opposite sides of the lighthouse, find the distance between the two ships, okay? So let's see how this will look like, how to draw this diagram. Okay, now this is your lighthouse, okay? This is your lighthouse. Let's call this CD to be your lighthouse. And this is your sea level or the ground level, okay? Fine. Now you see that the angle of depression of two ships A and B as observed from the top of the lighthouse 60 meters high, which means that the height of this lighthouse is 60 meters. Okay. Now the angles of depression are given here. Okay, two ships which are on the opposite sides of the river or the sea. Okay, so you have, let's say, one ship over here. Okay, let's say call this A, and let's say I have another ship, let's say here B. Okay, now you see that the angles of depression are given, right? The angle of depression means that the object is at a lower position, that is A and B. These are the objects. Where is the observer? The observer is standing at the top of the lighthouse. Okay, so this is his line of sight. The observer is standing at the top of the lighthouse with this line of sight, with CA as the line of sight and CB as the line of sight. Okay, so this is the observer. Okay, and he observes the angle of depression to be 60 degree and 45 degree. Now, what do you mean by angle of depression? Angle of depression is the angle made with the horizontal, right? With the line of sight of the observer. So line of sight are CA and CB, and the horizontal is this line that I have drawn, this vertical line. So this angle here, one angle here is 60 degree angle of depression, and the other angle here is 45 degree. These two angles are given to you. Now, if this angle is 60 degree, this angle must also be 60 degree because they are alternate angles. And this angle is must be 45 degree because they are alternate angles, right? Now let's see the question. Question is, find the distance between the ships. Give your answer correct to the nearest whole number. What is the distance between the ships? This AB is the distance between the ships that we need to find out. Okay. So what all are given? 60 degree, 45 degree angles are given, and the height of the lighthouse is given. With the help of these two information, you will have to find out the distance between the ships. Okay. So let's see how to find out. First of all, you can see this right angle triangle ADC, and you can see the other right angle triangle BDC, right? So consider the first right angle triangle in triangle ADC. We use tan here once again. Tan 60 is equal to CD by AD, right? In this right angle triangle. Now tan 60, you know, is root 3. CD is 60, and we can find out AD from here. So that means now what is the value of AD? So we have AD into root 3. After cross multiplying, we get AD into root 3 is equal to 60. That means we get AD is equal to 60 by root 3. Rationalize the denominator by multiplying the numerator and denominator by root 3. So 60 into root 3 divided by root 3 into root 3. So you get 60 root 3 by 3. So this cancels here. You get only 20 root 3 meters. That is the unit, because the height of the tower is given, or the height of the lighthouse is given in meters. So you have got this distance as 20 root 3 meters. Okay. Now we'll consider this right angle triangle. So in triangle BDC, Again, use tan 45 degree is equal to CD divided by BD, perpendicular by base. Okay, tan 45 is 1. The length of CD is nothing but the height of the lighthouse, which is given to you as 60 meters. And from here, you can find out BD. That means you get BD is equal to 60 meters, right? So this length you are getting as 60 meters. So therefore, what is the total length? What is the distance between the ships? 60 plus 20 root 3. That is the total length, right? So hence, distance between the two ships at A and B is AB equal to AD plus BD, okay, which is equal to AD, we have calculated this as 20 root 3, and BD we calculated above to be 60, right? Now they have asked you the answer in to the nearest whole number, okay? So we want to convert this to the nearest whole number. How do we convert this? What you do is you can take out 20 common to get root 3 plus 3, right? 20, and you know the value of root 3 as 1.732 plus 3. So you get 20 into, now you can add these two, 3 plus 1.732 will give you 4.732. And when you multiply these two, you are going to get 94.64 meters. But they have asked you the answer to the nearest meter. So the nearest meter means 94.64 is greater than 94.5, isn't it? Right? So therefore, your answer will be 96 meters. Correct to the nearest whole number. Okay. So this was a type 2 problem. Okay. Now in this type of problem, if you see, the length of the height of the lighthouse was given to you, and you were supposed to find out the distance between the ships, this distance. Now in the second, the problem in problem 4, the next type 2 problem, we will see that this length will be given to you, and the height of the lighthouse you will have to find out. Okay, this is the diagram will be the same, except what you need to find out will simply change. Okay, so let's see how to find out to the next problem. This is a variation of type 2 problem. The diagram obviously will remain the same. Now let's see what is given here. In this question, it is given that the angle of elevation of a pillar from a point A on the ground is 45 degree. Well, so a pillar is there. Okay, this time instead of a cliff or a lighthouse, a pillar is there. Okay, let's call the pillar CD. Okay, the angle of elevation of a pillar from a point A on the ground. So angle of elevation is given. Angle of elevation is given means the observer is in the depressed position. That means observer is down, right? So let's say this is a point A, and here you have one observer. Okay, this is the object. He is looking on top because angle of elevation is given. And what is his line of sight? This is his line of sight, AC. He's looking at the top because angle of elevation is given. Let's draw the ground level also. This is your ground level. Okay. So angle of elevation of this pillar from a point A on the ground is 45 degrees. So this angle here is 45 degrees, right? And from a point B, diametrically opposite to A. Diametrically opposite means on the opposite side. That means on the opposite side of the pillar or the cliff or whatever vertical obstruction is there. Okay. So diametrically opposite, you have another observer here, B, who is looking at the top of this pillar, right? And his angle of elevation is given to be 60 degrees. So therefore, this angle here is 60 degrees. Okay, fine. And now the question is, find the height of the pillar, that is, find the height CD. Just as I told you, that this time you will have to find this, the height of the pillar CD, given the distance between A and B. So this is your distance between A and B, which is given to you. How much is distance given? This distance is given to be 15 meters. Okay. Now in this, again, the concept remains exactly the same. That is, we are going to use these two right angle triangles, ADC and BDC, except that the unknown part has just changed. Okay, this time we have to find out the height of the pillar instead of the distance between A and B. Okay, now in order to find out the distance between A and B, you take this distance as X, that is AD as X and BD as Y. Okay, and you take the height of this pillar as H. Okay, so remember, whenever you have to find out the height, always take the height as H and AD as X and BD as Y. And now we are going to use these two right angle triangles in order to find out the height of this pillar. Okay, so how do you find out? First of all, see that when I have taken this as X and this as Y, that means the entire length is given. That means we must have X plus Y is equal to 15. So here let ED is equal to X, BD is equal to Y, and the height of the pillar be H. And the height of the pillar be H. So therefore, if you see X plus Y must be equal to 15, right? This is what is given to you. Let us call this equation as equation number 1. Now we are going to use the two right angle triangles. Look at the right angle triangle ADC, that is this right angle triangle. So in triangle ADC, okay, you have tan 45 degree is equal to CD by AD. The value of tan 45 is 1. CD we have taken as H and AD we have taken as X. So that means, what are we getting? We are getting H is equal to X. Call this 2. Okay. So with the help of this right angle triangle, we have got an equation in H and X. Now we are going to use this right angle triangle, that is BDC. So in triangle BDC, okay, tan 60 degree is equal to CD by BD. Okay, tan 60, the value of tan 60 is root 3. CD we have taken as H, BD we have taken as Y. So we are getting H is equal to root 3 Y, right? Call this 3. Okay. Now from these equations 1, 2 and 3, we want to find out H. Okay, so how do you find out H here? In this, if you see 2 and 3 are simultaneous. If you see H is equal to X in 2 and H is equal to root 3 Y in this. So from 2 and 3 we get both, since both are equal to H, from 2 and 3, what can you write? X is equal to root 3 Y, isn't it? Because here H is equal to X and here H is equal to root 3 Y. So you can write X is equal to root 3 Y. Call this 4. Now you see this equation here is an equation in X and Y, and this equation here is an equation in X and Y, right? Which you can solve. Let's solve for x and y. In fact, because we have h is equal to x, if we simply solve for x, if we just find out the value of x, we'll be able to find out h, because h and x are equal, right? So how do we solve these two equations? What you do here is, um, if you want to use the elimination method, from 4, um, x is equal to root 3y. Yeah, because we want to find out, okay, fine. X is equal to root 3y. Putting this value in 2. Okay, we get, putting this value in 1, sorry, not 2. We get x is root 3y plus y is equal to 15, right? So you get y, you can take y common, you get root 3 plus 1 is equal to 15. That means you get y is equal to 15 by root 3 plus 1, right? We have solved for y. Let us now find out the value of x. How do you find out the value of x? Uh, you put the value of y in 4. So from 4, x is equal to root 3 y. And what is the value of y we have found above? Root 3, 15 by root 3 plus 1, right? This is the value of x, which is equal to 15 root 3 divided by root 3 plus 1. Okay, now because if you see the question here states, uh, find the height of the pillar, they have not asked you to find out the height of the pillar correct to the near to 2 decimal places or correct to the nearest meters. So therefore, you can you have the liberty to leave the answer here. You will get full marks, right? But if the question was to find out the height of the pillar correct to the nearest meter, then you will have to rationalize the denominator. Let's rationalize the denominator and finish the story of this problem. Is root 3 minus 1, multiply the numerator and denominator by the rationalizing factor, root 3 plus 1 into root 3 minus 1, right? So you get 15 root 3 into root 3 minus 1 divided by, and you have here root 3 square minus 1 square. So you have 15 root 3 into root 3 minus 1 divided by 3 minus 1 will give you 2, right? So now you have 15. What you do is you multiply this, only this single root 3 with this root 3. You keep 15 out as it is. So root 3 into root 3 will give you 3 minus, and this root 3 into 1 will give you a root 3 divided by 2, right? So now what you get is 15. Now you can put the value of root 3 as 1.732 divided by 2. So that gives you 15 into 3 minus 1.732 will give you 1.268 divided by 2. Now you can cancel this here by 0.634. So you get here 9.51 meters. This is correct to 2 decimal places. Although in the question they have not asked you, but I'm just to show you, if they ask you correct to 2 decimal places, this is how you are going to do. Correct to 2 decimal places. Okay. But if they ask you correct to the nearest meter, then what should be your answer? This if you see, this number is clearly greater than 9.5, right? So if they ask you correct to the nearest meter, your answer will be 10 meters. Correct to the nearest meter. Okay. So that is how these problems are solved. Okay, now in all the problems that you will get in the following in the exercises in the that is given in the textbook, all these problems in some way or the other, they will be either of type 1 or type 2. So if you have understood the type 1 and type 2 problems well, you should not have problem solving the questions from the textbook, all the other problems, because in some way, uh, in some twisted way or the other, all of these are related. Okay, so I'll stop here.